All right. So yeah, thanks again for having me back. This
Hey,
is
Jordan,
yeah,
can you just speak up a little bit? It's a little bit of an echo. Just want to make sure everyone can hear you clearly.
yeah. Hold on. Let me make sure I have the right mic on.
And again, for those of you out there in the Angelbeat online community, any kind of technology issue or question, just put it in the chat or the Q&A.
All right. Can you hear me now, Ron?
Yeah, I think that's fine. Again,
Okay.
Charles, everyone else out there, please comment if you need Jordan to speak louder.
Cool. All right. So I am Jordan Thurston. I'm a senior solutions architect here at AWS. I've been here for coming up on 2 years. But prior to this, I've been working in technology for about 15, 16 years, focusing on migrating and modernizing legacy applications to move them into the cloud and into AWS specifically. Today, we're going to talk about serverless architecture patterns. So we're going to talk through some of the most common patterns that we see that customers are following to leverage serverless. We'll also touch on a little bit about why they're looking at serverless and really what serverless is. I'm going to just briefly touch on that because serverless has been around for quite some time now. So I'm sure many of you have at least some familiarity with it, or if not using it on a regular basis. Um, Actually, in fact, Lambda, one of our core serverless services, was actually launched in November of 2014. So we are coming up on a decade of serverless here at AWS. So I don't want to spend too much time. I'd rather get into the patterns that we're seeing, but let's go ahead and get started. So I think we all agree that a lot of businesses these days are facing a lot of growing pressure. So they need to innovate to be able to meet all of their changing customer needs and really stand out in the market. They need to make sure that they are staying secure and resilient and compliant. Regulations are changing on a daily basis, so customers are going to need to keep up there. They need to be able to respond quickly to events and various things that are happening within their systems and their applications. And they need to keep an eye on, of course, their top line revenues and how to optimize costs. So as our customers are looking to increase the pace of innovation and build new experiences, they're increasingly modernizing and changing the way that they build and operate applications. And one of the main ways that we see that they're doing that is by adopting the serverless operating model. So what is serverless? Uh, so first, we'll start with the operational model. So an operational model, by definition, are the people, processes, and tools across the board on how you do something. So when we're talking about AWS or cloud infrastructure, in our case, we're talking about software development and how you build and run applications. And serverless can really help drive higher velocity and better productivity across that model. So we talked about how you can move faster with Gen AI and how you can move faster by leveraging open source and not have to start from scratch. Serverless is just yet another way that you can increase that velocity and improve productivity of your development teams. So on the picture we have here, when you're using serverless with AWS, it allows us to take on the responsibility of managing the physical infrastructure, the compute services, the storage and databases, and as well as messaging and orchestration behind the scenes. That allows you to focus on your API layer and your business logic. So really having your developers spend time on the things that are going to make the most impact to your customers and not have to worry about all of that underlying undifferentiated heavy lifting. So at the end of the day, by leveraging serverless and letting AWS handle all of that underlying infrastructure and services, it allows you to get to the market faster and really focus on what your business needs. It allows you to lower the cost of your total cost of ownership because you're only paying for what you use. So you're not paying for a server just sitting in a rack somewhere that's running 24/7. By leveraging serverless, you're only paying for when your services are turned on and actually doing work. It allows better for performance and scalability because you're, again, not relying on hardware. So you don't have to wait for servers to get provisioned, get delivered, get installed, all of that stuff. it immediately allows for higher performance and scalability. It is all architected into our services. And on the same page, security and operational resilience are also by design included in all of our serverless services because we know that you're not concerned with the server or the underlying infrastructure. We take that on and we build in security and operational resilience at that layer so that you do not have to worry about it. So that's all great and well. So how do we actually do this? So AWS has the widest portfolio of serverless services for running and building modern applications. Now, this is just a high-level snapshot, and this is changing on a regular basis. But you'll see that we have primitives on the left. So we've got compute, containers, ways to manage events, ways to manage messaging, storage, all of that there. And then on the right, we have our peripherals. So we're talking about different database models, more workflow orchestration, as well as analytics. And again, this is just a quick snapshot. There are many, many more services within our serverless portfolio, and we are adding to them at a regular basis. On the top left here, you will see AWS Lambda, and this is the one that I was mentioning has been around since 2014. And this is one of our core serverless compute services, which allows you to run a block of code that was triggered by an event. The code will run, and then when the job is done, the Lambda will shut down. And this is really a really good illustration of that pay for what you use or pay as you go model, because you can get billed down to the millisecond for that Lambda. So if it's up and running, you're getting charged, but the moment it shuts down, you're no longer getting charged. And that's the same model for all of our serverless capabilities, because you're not paying for that box in the server room or that box in the data center. You're only paying for the active services that are running. So we'll get into some of these as we work through the various patterns, but I wanted you at least to see how broad our offerings are in the serverless area. But yeah, let's get into some of the most popular patterns that we're seeing with customers as they do move to adopt serverless technologies and really benefit from that serverless operational model. So we'll start out with the basics. So just your standard 3-tier web service. So you've got your client on the left that's making an HTTP call, whether to an API or an endpoint, web application. That request then gets routed to your application layer. So this is where your compute is. And then from there, you're going to route back to maybe a relational database. Maybe you have to pull some data that has been stored in a database somewhere that will transform and modify this request and send it back to the client. So how do we do this on AWS? Pretty straightforward. So each of those layers will get transformed to an AWS service. So starting on the left, we have our API gateway. API gateway is our managed API service for REST APIs and WebSockets. API gateway integrates with countless AWS services natively, but the most popular integration we see is with our Lambda service. You're going to see Lambda a lot in my presentation today because it really is that core serverless capability. So in this workflow, your client makes a call to the API gateway. API gateway immediately triggers your Lambda function, which can run, again, that serverless code. So once again, you're not worrying about the server that it's running on. It is completely managed by us. That function in this example could then make a call back to DynamoDB. DynamoDB is our, again, serverless, fully managed, NoSQL database. So yet again, another serverless service on AWS that is completely managed by us, but it brings all of the NoSQL database capabilities to your applications. So client calls the API gateway calls Lambda, Lambda reads from the DynamoDB, and then that request routes back to the client. So pretty straightforward, but this is one of our most common patterns that we see because it is so straightforward. Get the slide to work here. Okay, so just high level, what were we talking about here? So the use case for this was a basic 3-tier web application. So web server, compute layer, and database layer. Some of the benefits to this are that they're simple to deploy. So again, with all serverless services, you do not have to worry about procurement to order servers. Don't have to worry about them coming in. So it's all simple to deploy. So all three of those services, as well as all of the others that we'll talk about today, can be deployed with just a few clicks, minor configuration, and you're up and running. Another benefit is that you can easily scale with Lambda's high concurrency capabilities. Lambda natively will automatically scale out to meet the needs of your application. So in our diagram, we only saw a few users. As those users grow, Lambda will automatically scale out to meet the needs of your application. Some considerations when you are looking at this pattern is that API Gateway does have a top limit of a 30-second timeout. So if you're looking for more longer running jobs where your web services may need to stay running longer, there are some other options that we can look at, but this is now a soft limit. So prior to probably 6 months ago, this was a hard limit that we could not increase. However, now we have announced the capability to increase our API Gateway timeouts beyond that 30 seconds. There is a trade-off that it would reduce your request per second. So as you're making these architectural decisions on how to build out your applications for maybe some of the use cases that do have the longer running jobs, know that there is a trade-off with your timeout length and the request per second. Another consideration with this pattern is that you should look at possibly implementing a circuit breaker pattern. And that's one of the patterns we'll talk about in a few slides, but it just adds some additional resiliency to this straightforward pattern. The next pattern we want to touch on is the gatekeeper. And now this is, again, the same basic three-tier web application, however, baked in with authentication and authorization. And when you're adding additional security to your web applications, there are a few different ways you can go about it. The diagram here shows how you can use a Lambda authorizer, which is a built-in capability of API Gateway, which when triggered will actually call a separate Lambda, and it can do a number of different operations within that Lambda, but one could be potentially accepting a Java Web Token from the client and then validate it against some information that's stored in your another DynamoDB database. So the API Gateway would then trigger that Lambda authorizer, validate that the user is one, who they say they are, and also has access to the resources behind that API Gateway that they're trying to call. And then it would pass either a yes or no response back to the API Gateway, and then follow on that same flow that we just talked about. So you still get all the benefits of serverless. You can still follow that same basic three-tier web application pattern. However, now it's much more secure because you've added in additional authentication and authorization while still staying serverless. Another option when it comes to authentication and authorization is to leverage our Cognito service, which allows you to leverage external third-party identity providers, as well as various social media logins. So your Google credentials, it could be your Azure AD, it could be Facebook. Cognito allows you to bring in identities from other providers and leverage their identity management, but still use that flow to log into applications that are built on AWS. The next pattern we're going to talk about is the strangler pattern. And this one is very popular. In fact, Ron actually had me do a session last year entirely on the strangler pattern. That's how popular this one is. And this is a pattern that is frequently used when customers are migrating their legacy applications either from on-prem to the cloud or even from virtual servers to a serverless architecture. The way that this works is by you taking your legacy application and slowly breaking it up into smaller microservices. So the example here is we have our legacy app that is currently deployed on EC2, but we've broken out the user microservice, which you can see here is now built of a Lambda and a DynamoDB. So we're breaking up the monolith, splitting this into serverless services, and then establishing it as its own microservice. That's great. Now, why doesn't that break the legacy app? What we've done in this pattern is put a load balancer in front of it. So now when your client accesses this application, the load balancer is going to route that traffic to the appropriate backend resource. So for this example, if that client is trying to add a user to the application, the load balancer is going to route that traffic to the Lambda that we see here, which would then go and add that user to the DynamoDB table in the backend of this application. However, if they're trying to perform any other function of the application that has not been decoupled or deconstructed, we can see here that we have a route for a /star. So that just means that load balancer is going to route any other traffic back to that legacy app. So this allows you to slowly break down those monoliths and those applications out into various different microservices and get off of the reliance of servers and move over to a serverless pattern. However, another additional piece to this pattern here is the addition of DynamoDB streams. So many legacy applications may have values hard-coded or rely on local data. May not always be the best practice, but I think all of us can agree when you're working with legacy applications, they haven't always been built in the most straightforward way. So a way that we can kind of close the loop there is by leveraging DynamoDB streams and change data capture to then trigger another Lambda to write any changes back into the local storage of that application that could be stored on that EC2. And again, this is just step one in the process where you would continue to replicate this pattern for each microservice that you extract out of that legacy application until you get down to the last function, and then you can actually go ahead and retire that EC2, and then you are no longer worrying about that service. So we talked through this. The use case is gradually migrating that legacy application to cloud native. Another example is migrating off of a server-based solution into a serverless solution. The benefits are it allows the development team to focus on incrementally building out that functionality without having to manage a fleet of servers. So instead of taking this giant monolith legacy application and pulling out those microservices and actually going and spinning up a server on its own, by leveraging this pattern, you can use services like Lambda and DynamoDB to keep it completely serverless and slowly migrate away from the headaches of having to manage that hardware and that underlying infrastructure. We also call out API Gateway and Lambda at Edge, which is another way that you could build that facade. So in our diagram, we showed using a load balancer. API Gateway and Lambda at Edge just add some additional capability to the front end of the Strangler pattern. And another thing to consider is that legacy systems may not always be designed to have the same levels of responsiveness. So we all know that if it is built on an older server, sometimes things respond a little slower. So another way to kind of resolve that issue is, again, with the circuit breaker pattern, which we're going to get to next. So we've mentioned this circuit breaker pattern a few times now. And this is a pattern that we see a lot because it improves the resiliency of your application and it isolates any failing services and prevents cascading failures. Because of that, it can improve the overall responsiveness by preventing long wait times for timeouts. And it also will decrease your cost because, as we said, you're paying for your services to be running. So if you have a Lambda that is calling an external service, for example, and that service times out, you're going to be charged the entire time that the Lambda is running. So this pattern will show you how to avoid all of those additional costs for those long running jobs. So in this pattern, we're going to walk through this one a little bit slower than some of the others. So let's say your client calls the API gateway, which we've seen, which then triggers the Lambda. Your Lambda now, instead of calling another service immediately, is going to check a DynamoDB table to see how many errors have been logged for that external service or that dependency. So in this diagram, this external service could be a third-party API outside of your organization, or it could be the legacy app that we just showed in the previous diagram. So the Lambda is going to check the DynamoDB table to see how many errors have been logged. And if that error count is lower than your configured threshold, then it will call that external service and pass the response back to your client. However, if that client calls the API gateway, Lambda checks the DynamoDB table, the error count is less than the threshold, it calls the external service. Now let's say that service is down. Your Lambda is now sitting there and spinning and waiting for the external service to actually throw a timeout error. That timeout error will then go back to your Lambda, get passed to your client. And then with the circuit breaker pattern, that Lambda will then also log an error event into EventBridge, which will trigger a second Lambda, and it'll log that error with a time to live parameter in your DynamoDB table. The time to live parameter will leave that row in that database until that time is passed. So for example, if you have experience with this external service that you know every 3 minutes it gets a refresh. So if it's timing out, you know, just wait 3 minutes and it will be fine. So when we are inserting this error into our Dynamo database table, you can put a 3-minute time to live in there. And then that row, that item in that database will be deleted after that time. So let's walk through again. So the client calls the API gateway, your Lambda now checks your DynamoDB table, and let's say your threshold was set to 1. Well, we now see that there is an error in that DynamoDB table. So instead of calling that external service, waiting for the timeout to come from that service, racking up your costs, it now will immediately break the circuit and send an error back to your client right away saying that the service is down. So this saves your Lambda from making external calls, staying running, and it provides a better experience for your client because they get that error back much faster. Now, let's say your client continues to refresh their page and this keeps happening. That same flow is going to happen until that error is gone from the DynamoDB table, at which point the Lambda will see that your error count is now below the threshold, and it'll call that external service again. And hopefully by now that service is back up and will return back to the happy path. If not, it will log the error and we'll start that new cycle again. So this helps with, again, racking up additional costs. It also can prevent the cascading errors. So let's say this external service was actually your legacy application. And now, instead of breaking the circuit, every time a new user is trying to refresh this, they're going to continue hitting that legacy application, which could in turn be proliferating the problem and make it even longer for it to recover. So the use case for the circuit breaker pattern is for calling external or internal APIs. And again, this reduces the racking up of costs, reduces the long wait times, improves responsiveness, and improves the customer experience because they're also not waiting. Again, better improve costs by tripping the workload and breaking the circuit. It also adds an additional capability of throttling and rate limiting. So by configuring those time to live parameters on your DynamoDB writes, you can really determine how often that initial Lambda is going to be making calls out or how long it's going to continue to throw the initial error. Another consideration to put here is that you can leverage DL queues or dead letter queues so that if this was, let's say, a backend processing job instead of a web application, when that Lambda would fail, or if it were to kind of break the circuit, you would log the error, but you also would log the initial call to another queue so that once the circuit is reopened, you can redrive those jobs and catch back up to any additional writes or modifications that you may have lost along the way. And I think I am close to time here. So just some action items. So this was just a very high level snapshot of some of the most common patterns that we've seen with serverless services. You can see many, many more if you go to serverlessland.com. And this is a constantly growing database of patterns leveraging our serverless services. So you can explore around here and search on basic use cases that you're working towards and see if there are already pre-built patterns out there. And if so, we will give you the tools and the utilities to mimic those patterns on your own solution. And when Ron shares out this deck, there actually are a few more patterns, but I am out of time here. But if you take a look at this deck and have any questions about any of the other patterns in this deck, any of the ones that we went over, or anything you find on Serverless Land, my contact information is on the last slide, so please feel free to reach out.